So let's talk about the section injection. So the section injection. Okay, and for this setup of this discussion, we're going to take K to be a field such that K cross hat, which is this inverse limit of K cross to the N, is infinite. Okay, and the examples are, so when K over Q is finite, a finite extension, K over QP is a finite extension, or when K is a real closed field, or when K is a discretely valued field. Okay, so these are some of the examples of when this holds. And so this is for a non-trivial Kummer theory. Okay, so so recall that if X over K is a scheme, and this is connected, so it's geometrically connected. So here K bar is the algebraic closure of K, and if we take so I'm not done yet. So if we take X to be a geometric point in here, we have a certain exact sequence. We have an exact sequence of fundamental groups here to pi 1 of, let's do this, GK. So the absolute Galois group of K. And then we have the geometric fundamental group here is the kernel of this map. Like so. Okay, so we have this exact sequence here. Let me make a little remark about GK. So note that if we take this X bar here from spec K bar to X, X goes down to F. So this is the structure map. Okay, so we get this dude here, which is F of X bar. Okay, and this induces some embedding of K into K bar. Okay, so this is what we need this. So we need this to make sense in embedding to define GK, right? And in actual, G subscript K, and in this context, GK is just pi 1 of spec K with respect to F of X bar, where F is that projection map. Okay, so we have this sequence here, okay, and it's given by a bunch of morphisms of pointed schemes. Okay, so we have the scheme over field, we have this whole thing, okay, and then we have this. So let me give you the false, let me give you a false statement about the section injection. So this kind of false statement. Okay, so so we're going to have, so given another point, X in, let's say, X of K, okay, this is a map, right, X from spec K to X, okay, this induces, okay, so we have normally this pi of X, it goes down to GK, okay, and it induces this section S of X, okay, so this is our structure map here. It induces S of X, and the hope is that these sections determine points for hyperbolic curves. curves. Okay, so again, what's a hyperbolic curve? So let's recall that a hyperbolic curve, so x inside here, so this is a proper curve or a projective curve, curve of genus G. Okay, xc is the complement. Okay, and we could have this number of xc, so this could be r, and then it's hyperbolic if 2g minus 2 plus r is positive. Okay, so this is what we want. So this is if and only if x is hyperbolic. Okay, so that's the definition of what it means to be hyperbolic. Another way to say this is that so that if you make this a divisor, right, you can take omega of x, twist it by d, so omega of x bar, twist it by d, and ask that the degree be positive. Okay, so this is what a hyperbolic curve is, okay? And so the section conjecture says that these sections will determine algebraic points for hyperbolic curves. Okay, so first, the first thing I want to say and why I was talking about this business here is because this statement doesn't parse. Okay, so this actually doesn't parse. Parse as stated. What do I mean by that? So note, we'll make an observation. Okay, that. Okay, so if I have a morphism of schemes, okay, so let's just do this completely generally. So in our setup, y we're going to be thinking of as spec k, okay, but we have this map x to y, okay, this is what we'll call f, and then we have this kind of section g, and g is a section, meaning that that g f, let's say g composed with f is equal to the identity on y. So this is g is a section. Okay, but we don't get that g, or that f composed with g is the identity on x. Okay, this is not true, and in particular, if so look what happens. So if we have pi 1, so we have pi 1 to x, and then we fix some base point here. Okay, and this goes from pi 1 to x, and then we have f of x bar, or sorry, y, f of x bar, like so. Okay, and now if we go back here, so this is the push forward map, this is the other push forward map, this goes from pi to pi 1 of x, g composed with f of x bar. Okay, and these two guys here are not the same. Okay, and so to get a map between them, so to get a map between these guys, we need to choose an isomorphism. And deal with indeterminacy. With only having this as an outer isomorphism. So indeterminacy. And by indeterminacy, I mean that this section is only going to be defined up to composition. Oh. So now let's state the correct form of the section injection. Okay, so given x to y, this is a morphism of schemes, and we have this guy here. Let's say over a field K. What do we get? We get this map here. And then after this, we what we get back is a bunch of sections. So a polymorphism of sections. So this will be a class of SG. So this will be a conjugacy class of sections. And or a polymorphism of sections. Okay, so if we denote, so let's let. Okay, so let me just state the theorem. So and I'll just write it out in words. So this is the section injection. Okay, so suppose K is a field with this guy is infinite. X over K is proper, and the genus is bigger than or equal to 2. Actually, we don't need this one. Actually, we don't need proper. The conjecture is what the conjecture that I'm going to have is for proper. But there's this natural map here, xk. To so it takes x, and it maps it to let's say sections. Let's call it gamma of pi 1 y. Okay, so we fix. So then we fix x bar, a closed point, pi 1 x bar. So these are sections, and then modulo conjugation. Okay, so conjugation in here, and we get this class of sections. Okay, so this maps to here. So the theorem is that this map here is injective. Okay, so that's the theorem. That's the section injection. So if we have a curve and we have a point, it's associated to a unique section, a unique conjugacy class of sections. So that's a section injection. Okay, so what's the section conjecture? So the conjecture is that when x over k is hyperbolic, and proper, okay, then this map, the sections, let's call it the section map, x maps to S of x. So S of x is the section here, is a bijection. Okay, so that's what the section conjecture states. All right.